So multiplexer. So other name for multiplexer as we can call it as MAX. So the main purpose of multiplexer is to perform high speed switching and can we can construct the multiplexer using basic electronic components. If it is used in the analog applications, you can use the transistor relays for designing the MUX. If it is used in the digital application, you can use the logic gates to design the multiplexer. Okay, so here we have so many types of multiplexer. In that few going to be seen here. That is 4 to 1 multiplexer. 4 to 1 multiplexer is nothing but 4 input, 1 output multiplexer. Here you will be having two control bits because 2 power 2. So 2 power to the 2 will give number of control bits or selective bits. Okay. So input, consider input signal as 0, D1, D2 and D3. And selected selective input, that is control input 2. So 2 will be denoted as A and B. Okay. The output signal, simply you call it as Y or Q. Okay. So here you are going to use logic gates for the design. AND gate, OR gate and NOT gate is used here. AND gate, OR gate, NOT gate. Okay. So A and B will be the selective input for input signal 0, 1, 2, 3. D of 0, D of 1, D of 2, D of 3. And then output is Q. Okay. So how you are going to select the signal, input signal for transmitting to the output side. Okay. So if your, for example, when your control bit AB is 0, 0. Okay. What will happen to the AND gate when your two inputs are high? What happened to the AND gate? What will be the AND gate output? When you are giving two input signal as low signal or 0 signal, you will be getting 0 as the output. Okay. Okay, it will not permit any input to pass through the AND gate. Okay. So the data D naught will be transmitted to the output Q. So if the control input is changed to 1, 1, then all gates will be restricted except the bottom AND gate. Okay. So bottom AND gate alone will not be restricted. Remaining that gates will be restricted. Okay. So you'll be getting D of 3 as the output for AB equal to 1, 1. Okay. So based on this selective input, you will be getting the output. If it is 0, 0, you will be getting D of 0 as the output. If it is 0, 1, D of 1 will be the output. 1, 0, D of 2. If it is 1, 1, D of 3 output will be produced at Q. Okay. This is the operation of multiplexer. So based on the selective inputs value only, you will be transmitting the input signal to the output side. Okay. This is multiplexer. So where you are going to apply the multiplexer means in communication system, in transmitter side of the communication system, you will be using this type of multiplexer, because in TV receiver also you can use. Okay, one of the example, TV receiver, radio receiver. So in TV receiver multiple channels are coming, but if from that you are using, you are selecting only particular channel. Okay, that is multiplexing. Okay. Computer memory, in computer memory also you can use the multiplexer for storing the um, data's telephone network. Okay, the calls will be selected. Okay, from the many multiple audio signals. Okay, and then transmission from computer system of a satellite. So computer system with the satellite. Okay, there also in the transmitter side you will be using the multiplexer. The next demultiplexer. So demultiplexer is opposite to multiplexer. There for multiplexer many into one output. Here one output many, sorry, one input many output. Okay. Multiplexer has many input, one output. Demultiplexer opposite to the multiplexer means single input, many output. Okay. So in the diagram, this is single input. Mistakenly here drawn as the output. It is not output, input. Single input, many outputs. Okay. So one input, multiple output line, which is used to send a signal to one of the various device. So one signal we have to send to many device. Okay. At that case, you will be using demultiplexer. Okay. So here we are going to see the example as for 1 to 4 demultiplexer. So 1 to 4 demultiplexer is nothing but one input, 4 output. So control bits will be 2. Okay. 2 is A, B. This is the control bits. So based on the control bit, you will be selecting the output. Okay. Y0, Y1, Y2, Y3. So when your control input is 0, 0, you'll be getting the Y0 as output. If it is 0, 1, Y1, if it is 1, 0, Y2, when both the bits are 1, 1, you'll be getting the output as Y3. So Y3 output alone, you will be getting a output for control bits 1 and 1. So அதுதான் இங்க கொடுத்திருப்பான். So where you are going to apply the demultiplexer means communication system. Okay, communication system la receiver side. Okay, you will be using the demultiplexer in communication receiver side. And then arithmetic logic unit. Arithmetic logic unit, that is performing the arithmetic and logical operation. Okay, there you will be using demultiplexer to decode the signal. And then serial to parallel converter. Serial to parallel converter means serial na bit by bit you will be sending the datas, but parallel means at a time you will be getting the all data value. Okay, or transmitting the all datas at a time. Okay. So for converting the serial bit into parallel bit, you will be using the demultiplexer. Okay. Then memory. So memories. So memory can be classified into two types: primary memory, secondary memory. So primary memory, otherwise called as main memory. Okay. So prime memory, under the prime memory, you will be reading RAM and ROM. So RAM is nothing but random access memory. ROM, read only memory. So in secondary memory, under that you'll be having two category. One is serial access memory and another one is semi-random access memory. So for example, for a serial access memory is magnetic tape. Okay, tape recorder. Okay, that semi-random access memory, floppy disk, hard disk. Okay, I think you all know what is floppy disk, hard disk, which is used in the computer system. Okay, so now we are going to see the primary memory. Primary memory commonly used in computer, RAM, ROM at all. Okay, so magnetic core memory, semiconductor memory, or will be coming under the prime memories. So first we are going to see the magnetic core memory. What is magnetic core memory? So there is nothing but which will be made up of small magnetic cores with wire running through them. That means magnetic core will be represented in a magnetic manner, which will be using electric current to flow in the direction of wire, so that the electricity which is flowing in the wire will be magnetized. Okay, magnetized in different direction. So the direction of magnetization will indicate the data representation of the CPU. Okay, so this form of memory is called magnetic core memory. This memory will be very bulky in size, so maximum it will be avoided to use. Nowadays we are using semiconductor memory instead of using magnetic core memory because of its size, because it is so bulky. So we are going to use new technologies, semiconductor memories instead of the magnetic core memory. So next, semiconductor memory. So the modern computer, entire modern computers are using semiconductor memories only as a primary storage unit. Okay, magnetic core will not be preferred in the modern computers, because here we are going to use silicon chip as a memory device. Okay, that silicon chip is nothing but rom and ram. பார்த்தீங்கன்னா உங்களுக்கே தெரியும், in your computer system if you say the memory, ram romலாம் பார்த்தீங்கன்னா it will be like a compact size, small size. Okay, so rom and ram will come under the semiconductor memories. So rom na read only memory, so it is permanently inbuilt in the computer at the time of its production itself. So rom memory is inbuilting memory. Okay, so for example in mobile you will be having internal memory, no, that is nothing but rom, read only memory. Okay, you will be having both read only memory as well as ram memory. Ram only memory only, you can able to write it. Okay, in read only memory you cannot write it. Okay, just you can read it, that's all. So you'll be having both rom memory as well as ram memory as a internal memory in your phone as well as your computer system. Okay, so rom, other name for rom is firmware. uh, it can store the group of instruction permanently, it will not be deleted. Okay, because it is inbuilt memory uh, when you are producing the product itself. Okay, so it cannot be deleted, so it just you can read, that's all, you cannot modify also. So maximum all will prefer the read only memory for storing the programs. Okay, and then one more type of memory in the rom itself, prom. Okay, modified rom device is prom, programmable read only memory. Just it is the variation of read only memory. Then ram, ram is you can read as well as write. Okay, both access is possible in the ram device, but read only memory la only reading access is possible, not writing access. Okay, you cannot write anything in the rom, but you can write and read in ram device. This will be acting as a computer's local memory, part of computer local's memory, where the computer stores all the data and instruction it receives from the input and the result as it works through the calculation. So whatever you want, you can save in the RAM device. Okay. RAM is short-term memory or volatile memory. What is volatile? Volatile is nothing but when the system is off, switch off, your details or message or information what you are storing in the RAM will be disappear. Okay, but a ROM will be permanent memory, but here this is a volatile memory. Okay, once the power is gone, your RAM device will lose everything. Okay, that is volatile, but it is the fast memory. Okay, so basic difference between ROM and RAM is given here. So a ROM is non-volatile, but a RAM is volatile. Once the power is switch off, everything will be lost. But a ROM like that will not happen. It will be acting as a permanent memory. It is a temporary memory, cost effective. This RAM is cost is high. Storage capacity will be available here highly. Here small storage capacity only. Speed processing will be high, sorry, low in rom but high in ram. Operating system will support the programs to store in the ROM device, but here this is a user defined programs. User can use the RAM device. Okay, but ROM device is used for operating system, OS. OS னு சொல்றோம் இல்லையா, OS only will be utilizing the ROM device, memory device in the system. Okay, computer system. Then PROM. So a commonly used version is the programmable ROM or PROM. Okay. Um, so maximum you will be preferring this PROM only, because the user can must write the desired program into it once by the special process. Subsequently, the content cannot be changed. So once you are written in the PROM, then it will not be changed. Okay, well, you are manufacturing the device. EPROM. What is EPROM? Erasable programmable read only memory. Okay, erasable programmable read only memory. So PROM, in the PROM you cannot modify the programs, but in EPROM you can modify it. Okay, that's the difference. That is erasable PROM, programmable read only memory. அப்புறம் double EPROM. What is double EPROM? Electrically erasable programmable read only memory. Okay, so electrically erasable means so while the power is cut off, okay, your program will be automatically disappear. Okay, at the electrically erasable programmable read only memory. And then secondary memory. So secondary memory, what's time now? Okay, so when the computer is switched off, anything stored in the RAM will be lost. Okay. So to avoid that situation, we will be going for secondary memory. Okay. Secondary, under the secondary memory, you will be using magnetic disk, floppy disk, um, so many things. Your CD, DVD, everything will come under secondary memories. Okay. So the storage capacity can be measured by bytes, bits, bytes, kilobits, kilobyte, okay, megabyte, gigabyte. Okay, if it is 1 byte, it will be equal to 8 bit. 8 bit தான் 1 byte ன்னு சொல்வீங்க. இதே 1024 bytes, 1024 means byte means 1024 into 8 will give the 1 kilobytes. 1024 kilobyte will be equal to 1 megabyte. 1024 megabyte will be equal to 1 gigabyte. This is nothing but storage capacity measurement. Okay. Then floppy disk. First we are going to see the floppy disk in secondary memory. So what is floppy disk? I think before CD DVD arrival, you will be using floppy disk only for the computer system, for using external storage. Okay, nowadays we are using CD DVD, but before that, floppy disk will be used, which will be like a plastic manner. Uh, for storing the information. This is made up of magnetic disk, but plastic, made up of plastic magnetic disk with a stiff envelope, radial slit, okay, which is used in the computer. Then hard disk. I think you all know what is hard disk, which is a permanent storage device. Okay, so you can store more information in the hard disk. Okay, so in the range of gigabytes only you will be using the hard disk. So the entire memory system, memories will be stored in the hard disk only. So you will be partitioning this hard disk into different sizes, which will be labeled as C, D, E. See here. See, C, D, E, F, G, H, I, J. Why I am getting this so many label means here I am using two type of two extra hard disk I'm using. That's why I'm getting this much label. Okay, C D E F G H I J. Okay, maximum one hard disk use பண்ணீங்கன்னா C D E F. That's all you will be having. You will be partitioning the hard disk into 4 or 5. That's all. Okay. So maximum size can be stored in this hard disk. See how many size? 199 GB, 300 GB, 431 GB, 100 GB, 100, 349, 165 GB. So many data can be, lot of information we can save in hard disk. Okay. அடுத்தது CD ROM. So CD-ROM, normal CD. Okay. CD ல பார்த்தீங்கன்னா you can read only memory, compact disk read only memory. So in read only memory you can read alone. Okay, once you are written, that cannot be modified in the read only memory CD. Okay. So advantages of CD-ROM is high storage capacity, then easily we can use in multimedia application, handle easily, can read or rewrite using CD rewrite. Okay, this is CD-ROM. Read only is possible, but write is not possible. If you are buying CD read write, then you can modify the datas in the CD. Okay, it is widely used because many of them using only CD for storing purpose. Disadvantage in patina CD writing needs to be done carefully because interruption in the process may lose the data. Okay, so and then it needs to be kept free from dust and heat. Okay, then magnetic tape. So magnetic tape is similar to your tape recorder cassette. Okay, for example. So it is one of the popular storage medium for storing large quantum of sequential data. So it is made up of plastic ribbon, usually half inch or a quarter inch wide, with 50 to 2400 feet long. So அதுக்குள்ள இருக்க magnetic tape பார்த்தீங்கன்னா it will be lengthy. You will be playing after getting damage of magnetic tape. It will be very lengthy. In sequential manner. It will be in serial manner. Okay. Advantage of magnetic tape is non-volatile memory. Voluminous data can store many data. Disadvantage பார்த்தீங்கன்னா only sequential data processing is possible. Complex mechanism is required. After few days, the data can be mounted to tape. We need to recall the data to store it into hard disk as and when required. So after few days, uh, you have to recall the data what you stored in the cassette. Okay, if you are not using for long period, then data will be lost in the magnetic tape. So cache memory next. So what is cache memory? Primary memory, secondary memory, cache memory. This is uh, tertiary memory, like okay, third memory. Primary memory, under the primary memory, you will be reading the RAM and ROM, which is the main memory. Secondary memories are nothing but CD, magnetic tape, and then hard disk. Everything will come under secondary memory. Cache memory. This is other than that secondary memory, like tertiary memory. Okay. So in between the CPU and main memories, that is primary and secondary memory, you will be placing the cache memory for interfacing. It will be acting as a buffer between main memory and CPU. Okay. It is used for temporary storage of data or programs. Okay. So advantages of using cache memory is it stores the current information and also it will reduce the access time, increase the performance, increase the speed of CPU, and access will be very fast. For speedy purpose, you will be using this cache memory, okay, which will be acting as a temporary memory device. Next one is virtual memory. So what is virtual memory? So once the speed is lost, what will be happen for the computer system speed? Loading problem will occur while you are accessing the data if your memory size is large, main memory size is large. Okay, at that time you will be using virtual memory. To avoid that, you will be using virtual memory to avoid the loading problems. Okay, to access easily, to access the data and programs easily, you will be using the virtual memory. So virtual memory is a memory management scheme that overcome this limitation by allowing the execution of process that might not be completely loaded in the main memory. Okay, so loading problem will be entirely avoided by using virtual memory because it's going to avoid the um, usage of main memory. Okay, so that you will be avoiding the problem of loading. So all the memories types characteristics are given in this table. You can compare it. So what are the technologies used? Capacity, average capacity of the memories in bytes are here. Technology used for designing the memory device is here, and then average access time. So with how much time that we can access. Okay, take the data from the memory, that will be given as the access time. Then purpose in a computer system, so why we are using the all these memories in the computer system, that reason is given here. Then relative cost per byte in units. Okay, that is relative cost per byte means so for 1 minute how many bytes will be transferred or accessed, that will be given here. Okay, that's all. So first unit over.